Hello everyone, my name is Sheela, working as an assistant professor in Chalapati Institute of Information and Technology. Today I want to discuss the topic is Introduction to Parallel Algorithms. So what is parallelism? Parallelism is the process of processing several set of instructions simultaneously. It reduces the total computational time. Parallelism can be implemented by using parallel computers, that is, a computer with many processors. Parallel computers require parallel algorithm, programming languages, compilers, and operating system that support multitasking. So next one is concurrent processing. The easy availability of computers along with growth of internet has changed the way we store and process data. We are living in a day and age where data is available in abundance. Every day we deal with huge volumes of data that require complex computing and that too in quick time. Sometimes we need to fetch data from similar or interrelated events that occur simultaneously. That is where we require concurrent processing that can divide a complex task and process it multiple systems to produce the output in quick time. The concurrent processing is essential where the task involves processing a huge block of complex data. For example, it includes accessing large databases, aircraft testing, astronomical calculations, atomic and nuclear physics, biomedical analysis, economic planning, image processing, robotics, weather forecasting, web-based services, etc. These are all the concurrent processing, examples of the concurrent processing. So before going to that, parallel algorithm, what is an algorithm? It is a sequence of instructions followed to solve a problem. While designing an algorithm, we should consider the architecture of computer on which the algorithm will be executed. As per the architecture, there are two types of computers, sequential computer and parallel computer. So depending on the architecture of computers, we have two types of algorithms. What are the sequential algorithm and the parallel algorithms? Coming to here in the sequential algorithm, an algorithm in which some consecutive steps of instructions are executed in a chronological order to solve a problem. In parallel algorithm, the problem is divided into sub-problems that are executed in parallel to get individual outputs. Later on, these individual outputs are combined together to get the final desired output. So to design an algorithm properly, we must have a clear idea of the basic model of computation in parallel computer. So for that, we have the different types of models are there. In both sequential and parallel, computers operate on a set of instructions called algorithm. These set of instructions instructs the computer about what it has to do in each step. Depending on the instruction stream and data stream, computer can be classified into four categories. Single instruction stream, single data stream, computer, that is SISD. Single instruction stream, multiple data stream, computers. Multiple instruction stream, single data stream, computers. Multiple instruction stream, multiple data stream, computers. So these are the four types of model of computations are there. So now we will discuss about the single stream, single instruction and single data stream computers. So here we can call a SISD computers. It contain one control unit and one processing unit and one memory unit. So this is the diagram representation from the control unit to processor by using the instruction stream. The instructions will be given to the processor, and after that from that memory to processor the data stream will be streamed. So in this type of computer, the processor receives a single stream of instructions from the control unit and operates on a single stream of data from the memory unit. During computation, at each step, the processor receives one instruction from the control unit and operates on a single data received from the memory unit. Next one is SIMD, single instruction multiple data stream. So here which it contains one control unit, multiple processing units and shared memory or interconnection network. So from this diagram we can see the control unit, which it is a single control unit, and multiple processing units are there, and that is shared or interconnection network. From that the data streams will be sended. So here one single control unit send instructions to all processing units. During computation at each step, all the processor receives a single set of instructions from the control unit and operates on different set of data from the memory unit. Each of the processing units has its own local memory unit to store both data and instructions. In SIMD computers, processors need to communicate among themselves. This is done by shared memory or by interconnection network. While some of the processors execute a set of instructions, the remaining processors wait for their next set of instructions. Instructions from the control unit decides which processor will be active or which processor will be inactive. So this is the SIMD computers. The next one is the MISD computers. MISD, multiple instruction stream single data stream computers. Here we have the multiple control units. As the name suggests, we have the multiple control units and multiple processor units and only one common memory. From this diagram we can see that multiple control units are there, and the multiple process, from the multiple process a number of instructions will be shared, and from that only single memory is there. Here each processor has its own control unit and they share a common memory unit. All the processors get instructions individually from their own unit, control unit, and they operate on a single stream of data as per the instructions they have received from their respective control units. The processor operates simultaneously. The next one is the MIMD, multiple instruction multi stream multiple instruction and multiple data stream. So here in this MIMD computers have multiple control units, multiple processing units and a shared memory or interconnection network. So from this diagram we can see that here each processor has its own control unit, a logical memory unit and arithmetic and logical unit. They receive different set of instructions from the respective control units and operates on different sets of data. In a MIMD computer that share a common memory is known as a multiprocessor, while those that uses an interconnection network is known as multi-computers. So based on the physical distance of the processors, multi-computers are of two types: multi-computer and the distributed systems. In this multi-computer, when all the processors are very close to one another, that is, for example, in the same room, that is known as a multi-computer. In the distributed system means where all the processors are far away from one another in different cities. For example, we can take in different cities. Those systems we are calling as a distributed systems. So there, this MIMD computers will be used. Now we will see the analysis of algorithm. Here, analysis of algorithm helps us determine whether the algorithm is useful or not. Generally, an algorithm is analyzed based upon its execution time, means time complexity, and the amount of space complexity it requires. Both the time complexity and the space complexity is required for the analysis of the algorithm. So, the same analysis of parallel algorithm which it contains, it is also sophisticated memory device available at a reasonable cost. Storage space is no longer an issue. Hence, space complexity is not given so much of importance in the parallel algorithm. Here it is designed to improve the computation speed of a computer. For analyzing a parallel algorithm, we normally consider the following parameters, that is time complexity. It is nothing but an execution time and the total number of processors it uses and what is the total cost. So these three majorly in the parallel algorithm, we will see the following parameters. So here speed up of an algorithm. The performance of a parallel algorithm is determined by calculating its speed up. Speed up is defined as the ratio of the worst case execution time of the fastest known sequential algorithm for a particular problem to the worst case execution time of the parallel algorithm. Here the speed up is equal to worst case execution time of the fastest known sequential for a particular problem by worst case execution time of the parallel algorithm. In this way, from this formula, the speed up of an algorithm will be calculated. So, number of processors used means how we can be used. It is the important factor in analyzing the efficiency of a parallel algorithm. The cost to buy, maintain and run the computers are calculated. Larger the number of processors used by an algorithm to solve a problem, more costly becomes the obtained result. And the last one is the total cost. The total cost of a parallel algorithm is the product of time complexity and the number of processors used in that particular algorithm. Total cost is equal to time complexity into number of processors used. Therefore, the efficiency of a parallel algorithm is equal to worst case execution time of sequential algorithm by worst case execution time of the parallel algorithm. In that way, we can calculate the parallel algorithms. So here in this parallel algorithms, only it will take the three parameters. What are the three parameters? Time complexity and total number of processors used and the total cost. Based upon this, the analysis of the parallel algorithm will be done. So I think so it's clear. Thank you.